everyone, welcome to Ecoholics. In this video, we'll be discussing partial differentiation. We use partial derivatives everywhere in economics. Let's say when we want to find marginal product of labor or marginal product of capital, everywhere we use partial derivatives. So let's understand what are partial derivatives. Now, partial differentiation. Let's say we have u, which is a function of x and y. What do we understand by partial derivatives in this case? So, partial derivative in this case is da by u by da by x and da by u by da by y. So, these are the partial derivatives. Now, what is da by u by da by x? This shows change in u with respect to x when our y is held as constant. So in this case, we are considering y as constant. And in this case, we have da by u by da by y. This shows change in u with respect to y, and here we have x as constant. So, we have da by u by da by x and da by u by da by y as partial derivatives. So, basically the concept of partial derivative is when we want to find change in u with respect to x, at that time we need to take y as constant, and when we are finding da by u by da by y, that is change in u with respect to y, we take x as constant. So, using the concept of partial derivatives, let's look at an example. Let's look at this example. Calculate da by q by da by L and da by q by da by k for the production function q is equal to L cube minus 2L square k plus 3LK square plus k cube. Now, in this case, we need to find two things. First, we need to find da by q by da by L, and next we need to find da by q by da by k. So basically we need to find change in q with respect to L when we have k as constant. And in this case, we need to find change in q with respect to k when L is held constant. Let's first calculate da by q by da by L. So, we'll first calculate da by q by da by L. Now, we have q as this. First, we are going to calculate da by q by da by L. So, in this case, what we are going to do is L cube minus 2L square k plus 3LK square plus k cube. So, we need to find derivative of these terms. Now, da by q by da by L, we need to differentiate with respect to L. So, when we are differentiating with respect to L, I have already told you that when we are differentiating with respect to L, we take k as constant in this case. So, we'll take k as constant. Now, we'll be differentiating these terms with respect to L, taking k as constant. So, first term we have L cube. So, we will be using power function rule of differentiation. So our power function rule of differentiation states that when our y is equal to x raised to n, then dy by dx will be equal to nx raised to n minus 1. So using this power function rule, let's understand what is the derivative of L cube. So in this case we have n as 3. So we get this as 3 L raised to, now 3 minus 1 is 2. So L cube, derivative for L cube is 3L square. Now derivative of 2L square k. Now when we are differentiating with respect to L, we take k as constant. So we have two constants, that is 2 and k. So we'll take them out and we are only going to differentiate L square. So now what do we get is 2k into, now differentiation of L square, again using our power function rule, we have 2 L raised to 2 minus 1 is 1. So this becomes equal to 2 2s are 4 k L. So now this becomes derivative for this term. Now we have already seen derivatives of these two terms. Let's calculate the derivative of other two terms. Now our next term is 3LK square. 3LK square. So in this case, since we are differentiating with respect to L, we have k as constant. So we have k as constant. Therefore, we have two constants in this case. We have 3 and k square, both constant. So we have 3 k square into, now differentiation of L. So what do we get is differentiation of L. 3k square, again using our power function rule, we have L raised to 1. So in this case n is equal to 1. So n as 1, L raised to 1 minus 1 is 0. So we have 3k square into 1, because L raised to 0 is 1. So we have 3k square. Let's calculate derivative for k cube now. Since we are differentiating with respect to L, we take k as constant. So when we take k as constant, then we know that derivative of a constant term is always 0. So this becomes equal to 0. Now substituting all these values, what do we get is daba q by daba L is equal to, now the derivative for L cube is 3L square minus derivative for this term 2L square k, what do we get is 4KL plus derivative for 3LK square, what do we get is 3k square. And lastly, derivative for k cube, we got this as 0. So we got daba q by daba L as 3L square minus 4KL plus 3k square. I'll write the final answer over here. So we get dabba q by dabba L as 3L square minus 4KL plus 3K square. So this becomes a final derivative. Now, similarly, we are going to calculate dabba q by dabba K. Now, we have dabba q by dabba K. So, we have already studied that a partial differentiation dabba q by dabba K. So, we are going to differentiate with respect to K and we are going to take L as constant. So, now dabba q by dabba K is equal to L cube minus 2L square K plus 3LK square plus K cube. We are going to differentiate each terms individually with respect to K now. So first we have L cube and we are going to differentiate with respect to K. Because we are going to differentiate it with respect to K and we are taking L as constant, we know that derivative of a constant term is always 0. Therefore, this term becomes equal to 0. Now, let's take other term. Other term we have 2L square K. Since we are differentiating with respect to K, we are going to take L term as constant. So here we have two terms constant, that is 2 and L square. So 2L square differentiation of K. Now, using a power function rule again. So our power function rule states that when y is equal to x raised to n, our dy by dx is equal to nx raised to n minus 1. Now, in this case, we have n as 1. So we have 1, k raised to 1 minus 1 is 0. So we get 2L square into 1 because k raised to 0 is 1. So because k raised to 0 is 1, therefore the final answer for this will become equal to 2L square. Now, let's calculate this. So we have 3L K square. Because we are differentiating with respect to K, we will take a L term as constant. So in this case, we have two constant terms, that is 3 and L. So 3L, and we are just going to differentiate it with, so we are just going to differentiate K square term. So here we have 3L into differentiation of K square. Now, using the power function rule, in this case we have n is equal to 2. So 2 k raised to 2 minus 1 is 1. So 3 2s are 6 L K. We have a final term, that is K cube. Differentiation of differentiation of k cube with respect to k. So again, using our power function rule, what we get is, in this case, we have n as 3. So we have 3 k raised to n minus 1. So n minus 1 in this case is 3 minus 1, that is 2. So now we are going to substitute all these values now. Therefore, dabba q by dabba k will be equal to, so dabba q by dabba k, L cube, for L cube we have 0. So we have 0 minus, for 2L square k, this term we have differentiated, what we got is 2L square. Next term is 3LK square. For this we have got our derivative as 6LK, this term. 6LK plus, for k cube what we have get is, for k cube what we have got is, we got 3k square. So dabba q by dabba k is equal to minus 2L square plus 6LK plus 3k square. So we get this term. So we got dabba q by dabba k as minus 2L square plus 6LK plus 3k square. So this completes our answer. So we have seen, we have calculated dabba q by dabba L, and we have also calculated dabba q by dabba k. So we have seen how simply we can use the concept of partial derivative and solve questions like these. So that's it for this video. In our future videos, we'll be discussing other concepts of mathematical economics. So do like and subscribe our channel. Thank you.